Okay, Mr. Fields here. We're going to do page 27 together. So we'll do these two. And then Dr. Conklin's video will do page 28, which is just one, but it's a little different because her video is going to have isosceles and right triangle. I asked her if I could do page 27 because it's easier. No, just kidding. But both of these are less steps than the one you're going to do here because if you look at this one, it just says, is it a right triangle? Prove that it's a right triangle. So it doesn't have anything to do with isosceles, just saying, is it a right triangle or isn't it? So I already plotted it, 0, 10, negative 8, 8, and negative 3, 5. So if you take a close look at this and somebody asked you, is that a right triangle? I think we would all agree that if it's a right triangle, then this would be the right angle. There is no way, and this isn't just a sketch, this is on graph paper. There's no way that that's 90, and there's no way that that's 90. Those are definitely acute angles. So the question is this one a 90-degree angle? It certainly looks like it could be, but we have to prove that. So how do you prove a 90-degree angle? You can prove 90 degrees, which is the same thing as perpendicular, if the slopes of those two sides are negative reciprocals, because that's how you prove 90 degrees perpendicular. So for example, if I had a slope of 10 over 3 and I had another slope of negative 3 over 10, those are negative reciprocals, upside down and different signs. So those two would be 90 degrees. So let's see. Obviously, the two that we're talking about are this one and this one, because they're the two that meet right here. So let's see what the green slope is, and then let's see what the orange slope is. So the green slope from here to here, so the slope of BC, and we know slope is rise over run, and rise could be fall. So let's see, down 3, and to the right 5. So negative 3, positive 5. Now we're hoping the other one's 5 over 3, but we're not sure yet. And yes, I know this problem was annoying because that point missed by 1, but it was only 1, so I think we could do okay and just do what I did and extend it by 1 box. But if it was more than 1, it would be a little tricky, but we made it work. So now we're going to do the slope of CA, which is its rise over run. And here we have up 1, 2, 3, 4, and a little tricky, but we have to go up one more, 5, and then over what would be 1, 2, 3. So we went up 5 to the right 3. And look what happened. Negative reciprocals. So these are perpendicular because they're negative reciprocals. So it just says, it doesn't say prove this time, it says, is it a right triangle? So yes, ABC is a right triangle. And it says, if so, what vertex is the right angle? Well, obviously angle C is the 90-degree right angle. No question about that, right? So the whole idea here is if you're ever asked to prove something is 90 or something is a right angle or a right triangle, you just find slopes of the two sides that meet, and if they are negative reciprocals, flipped and changed the signs, then you have a 90-degree angle. So number 4 is using the word prove. So it's almost exactly the same thing because I pretty much did prove it here. We'll just make a different concluding statement. So again, same thing happened here when I plotted it. I had to extend my graph a little bit, but only 1 over and 1 down, so it wasn't too crazy. So 5, 7, 11, -1, and 3, 3. So now we're asked to prove it is a right triangle. Same thing. If it's got 3 sides in a right angle, then it's a right triangle. So again, it's obvious that this must be the right angle if there is one. There's no way that that's acute, and that's even acuter. I don't think that's a word. Well, it is now. Who's going to stop me? So C is the possible right angle. So that means we have to find the slope of this one and this one because they meet right there. And if we find those two slopes and they're negative reciprocals, then we've proven it's a right triangle. So let's find, color-coded again, let's find the slope of CA, which we know is rise over run. Let's see, we're going to go up 1, 2, 3, 4, and to the right 2. So that slope is 4 over 2, which reduces to 2 over 1, or just 2. But I like fractions, so I'm just going to leave it 2 over 1, because it'll be easier to compare in a minute. So then, slope of CB. This is going to be down. Did I write rise over run? I didn't. Rise over run. And again, rise can be a fall. You can rise negative, which is weird, but you can. So down 1, 2, 3, 4. And to the right 1, 2, 3, 4, 5, 6, 7, 8. So -4, +8. -4 over 8. And that reduces, 4/8 is just 2/4, which is just 1/2, right? 4/8 is 1/2. So -1 over 2. And look what we have here. 2 over 1, and then the upside down negative, -1 over 2. So we can now say we have, I like to link them up and show that, yep, I knew that that was perpendicular. So you could say triangle ABC is a right triangle. And you could get crazy here, and it says prove that, actually it already says that it's a triangle, so you don't have to say anything about it having 3 sides. It's a right triangle because the slopes of CA and CB are negative reciprocals, which make a 90-degree angle. And there's a lot of ways you could word that. As long as you have this work here and here, and then you have a concluding statement that says it is a right triangle because, and then something about the slopes being negative reciprocals. So now you're going to watch the other video with Dr. Conklin where she'll do the same thing with the right triangle part, but she's also going to talk about the distances being isosceles. All right, we'll see you tomorrow with the live session.